So what we're going to take a look at now is how we can go about storing something like a password in our database. Now it goes without saying the worst thing that can happen to our application is that our database gets compromised in some way by some nasty hacker. And we need to consider that that's a possibility. So storing passwords in a database is kind of a big deal. How do we do it? Well, there's a few different options. Option 1, we could store the passwords in clear text, which is obviously a terrible idea because if somebody does compromise your database and gets access to all of the usernames, email addresses, and passwords, then you've got a problem. And you then have to tell your users that, their passwords have been compromised and they have to change them. Now, whatever happens, you're always going to need to do that. But if you're storing your users' passwords in a database like this, then clearly that's going to be a problem. Now, a couple of our users in this database, you could say, well, they deserve to be hacked. And there are things you can do about that, which is to not let them use such a weak password in the first place. But commonly used passwords like that, there's not much you can do. If you do allow weak passwords and somebody uses a weak password and they get compromised, not your database, then that's really the user's fault. But we still shouldn't store the passwords in clear text. It's a bad idea and we're not going to do that. So what we need to do is do something with a password. The user obviously enters their password in clear text. The password goes across the wire or the internet in clear text, but crucially, it's protected because we use SSL security to encrypt the data on the way from the client to the server. So we're fine with the users passing up their passwords to us in clear text. Now option 2 is hashing the password, which means that we take their password, we add or apply a hashing algorithm to it, and we end up with a password hash. And we store the password hash in the database. Now, hashing is one way only. You cannot calculate from a hash what it was before it was hashed. So in theory, this is a pretty secure way of storing our passwords. But the problem with this particular method is that Bob and Tom have continued to use their weak password of let me in. But when we calculate the password hash, then the same algorithm is applied to the same password, which means we get the same result. Now, if our database gets compromised, then the attacker knows that Bob and Tom have got exactly the same password. And if he can somehow calculate the password from this, then he's got access to 2 accounts. It's very common for users to use the same password for different applications, no matter how much we're advised against it. And the problem with just hashing a password is that online there are dictionaries of every possible commonly used or combination of different passwords available, and their hashes have already been computed in various different algorithms. So what somebody would be able to do is simply take that password hash, paste it into one of these online dictionaries, and boom, they have your password within a couple of seconds. So this is also not a great way of storing a password. Simply hashing it is not good enough. When it comes to working out if the user's typed in the correct password, then we can simply calculate the password hash and compare it with the hash that we're storing in our database. And that's what we would do, but like I say, this is still not good enough. Option 3 is hashing and salting the password. Now, a password salt or a salt applied to a hashing algorithm is going to scramble the hash. So even though Bob and Tom have once again used the same weak password, notice that they now have completely different password hashes. There is no way for an attacker to know that Bob and Tom have got exactly the same password. Now, we're also going to store the password salt. Now, the password salt is another randomized string that we pass into the computed hash that then scrambles the hash in some way to make it very different to the original calculated hash, which is why Bob and Tom now have different password hashes. And then when it comes to working out if they've added the correct password when they log in, we simply need to calculate the password hash using both the password they've supplied and the password salt in order to calculate the scrambled with the salt password hash. Now, this is a better way of doing it, and for simple basic authentication, this is how we're going to implement it right now, because it's easy to implement, and 90% of the code that we write to do this is going to be fine for when we take a look at what we're going to do later on when we further secure the application. This is to show you the concepts of authentication, what we're going to do in this section. It's not going to be a battle-hardened, bulletproof solution, and you shouldn't expect it to be. This is one step above adding completely fake authentication. This gives you the concept of how authentication works in a very visible way that we code ourselves. And just to cover some frequently asked questions, why don't I use ASP.NET Identity? I will. It's coming later, and you will see how to use that, I promise. But ASP.NET Identity gives us all of the code that we can just use. It's magic, it's great, and it does a lot of the work for us. But it doesn't really show us how it works, and you end up with more questions about how does this work, how do I know this is secure, than if we do it this way. So we're going to implement some very quick and easy, simple authentication into our application to help us out. Which is why the second question, why are we storing the password salt in the database, is another one that I'm just going to answer with it's very easy to do, and it's not the way that we're going to finish up by the time that we complete this application. Because later on, as it says, we will refactor to use the widely used and battle-hardened ASP.NET Core Identity. ASP.NET Identity has been around for years, and it's commonly used in many, many applications. So it goes without saying that that's been tried and tested, and you can presume that's going to be secure. What we're doing now is kind of secure, but I wouldn't use it in a real-world application. And this is just a learning exercise to show us A, how authentication works, and B, so we have something to work with in our application as we build it. So that's the concepts of what we're about to do, and let's go ahead and now implement this.